Testing, testing, testing. Probando, probando. Can you hear my voice, guys? Yes or not?
Yes, mister.
All right. Thank you so much. Sorry for the inconvenience, but now it's fixed. Son pequeños carrots. Okay. Welcome, everyone. It's good to see you again. Today we're going to, I don't know, it's recording. Yeah, recording the class. Today we're going to start with the first physics lesson in the year 2021 and 2022, right? So the first topic is the chapter number 9. We're using the survey and build textbook, right? The night edition. Don't worry about it. I'm going to upload again the textbook. All right. This is continuing with the last chapter. Remember, we studied the last chapter that we studied was torque and rotation of rigid bodies. Well, this time we're going to talking about mechanical fluids and fluids and solids. Okay. One of the first lesson we're going to learn how to identify what will be the difference between density pressure and a specific weight of the system. Because some people, even though teachers or physics teachers, could you imagine, they're using a capital letter D like demonstrate this is the density, but that's wrong. The capital letter D, that is a symbol representing that specific weight. And that mathematical symbol that will be density in the situation has the name in the Greek alphabet. That means rho, rho. As soon as you can hear that, rho, R-H-O, rho, rho, rho. This is the name of that letter that will be represent the density. All right, what we're going to learn in solids of fluids. We are obviously going to learn the definition of density, specific weight, and specific gravity. Obviously, we're going to learn how to calculate the pressure for any materials. After that, we're going to learn how to calculate the deformation of solids. And after that, we're going to apply the Pascal principles, Archimedes principle, and the Bernoulli's principle, and the principle of continuity. Well, but in a few lessons later, all right? We're going to start step by step in that situation with the first unit of the problem. And in this lesson, you have studied that already in chemistry class and also in the science class a few years ago. For example, what is the definition of density? Well, density is the proportion relationship between the mass per unit of volume. Simplementary words, mass divided by volume. Well, as you can see, this letter will be represent the density is the Greek alphabet letter that will be represent rho. This is the name of this letter. That will be density and represents the mass, and B will be represents the volume of any system. Okay, this volume in the, well, this unit in the international system and British system, as you can see, the density is given by kilograms per cubic meters in the international system. You know, the international system is using in Latin America and Europe. And the British system is using England, the British Union, and also the US. But this is the difference between them. The second unit is slot, is the linear unit gravitation per cubic feet. The unit for mass is kilograms, and another one is slot. Not slot. Slot is another thing. But this is slot, S-L-U-D, right? And the volume is cubic meters, and as soon as you can see, the British system is cubic feet. All right. This is the few difference between the units. Okay, and we're going to talking about what is the difference between density, specific weight, and obviously the specific gravity. These are two different components. I'm going to give an example. The specific weight in this situation, guys, is going to use the capital letter D. This is not representing density. This is representing that specific weight. And the definition, the specific weight of substance, both are the same. Can be divided by the division between the weight of any body divided by the volume, or if you wish, we can multiply the density times the gravity. Remember, the unit weight will be the units of this specific weight. Well, if you see the international system will be Newton per cubic meter, and the British system pound cubic feet. The units of weight, international system, remember the weight is a force, is given by Newton, and the British system is given by pound. And the gravity, remember the gravity is a constant value, and free-falling objects, that will be given constant value of 9.8 meters per second square in the international system, and also 32 feet per second square in the British system. All right, this is the difference between them. A few seconds ago, I told you already, both formulas are the same. I'm going to prove just a little demonstration. As soon as you can see, we have the specific weight. The specific weight is the relationship between the weight for any body divided by the volume, right? Yes or not? So, do you remember what is the formula for the weight? What is the formula for weight?
Mass times gravity.
Exactly, weight equals mass times gravity. Okay, let's going to change that one. Instead to use weight, we're going to change by mass times gravity divided by volume. Okay, so as soon as you can see, if you can see that relationship, we have a proportion located over here. Mass and volume. Mass divided by volume. If you really want to clarify, we can split their product with their fractions just like this way. I mean, density equals mass over volume multiplying by the gravity. You know, the gravity has a number, one imaginary number. If we're multiplying the fractions, we can multiply numerator with numerator and denominator with denominator. So if you see to the left side, we have a relationship between the mass and volume. And what is the relationship between the mass and volume? What is that? What does that mean? Mass divided by volume. What is mass divided by volume?
Density.
Density. For that reason, that specific weight can be calculated multiplying density multiplying by the gravity. This is just for let you know, just for clarify the demonstration why both formulas are the same. We can use weight divided by volume or density multiplied by the gravity. At the end, both will be the same. When we're going to use both formulas, depending the data of the problem, depending the case, okay? But there's a third relationship. We're talking about density, we're talking about a specific weight, but I mentioned one significant term that will be the specific gravity. Specific gravity is a simple way to calculate the situation. The specific gravity, GE, that means specific gravity, is the relationship between the density of the object, the liquid. When I give you an example, all right, divided by the density of H2O. Simple matter word, the density of the liquid divided by the density of the water, we're going to have a specific gravity. Why we have to divide the density of any liquid divided by the density of the water? Because the amount of the bodies in this and lives in the planet Earth, the planet Earth, as soon as you can see, is composed like 80% of water. Actually, the human body is composed by 30% of water. I don't know if you know that already, okay? But even though the wood, this wood, as soon as you can see this piece of wood, it contains some kind of percentage of water. Unbelievable, but it has water. For that reason, if you really want to know what is that percentage, I mean that specific gravity is the percentage of density of water that anybody has in singular situation. For that reason, the specific gravity it doesn't have unit because it's a number. It's a security factor which determines what will be the quantity of water that anybody has in one single situation. For example, if I give you the specific gravity of any substance, it could be 1.2. If I really know what will be the liquid density, the only thing that I have to do is density of water divided by the multiply. And, you know, I don't know if you know that already, but the density of water has the constant value. The density of water has a constant value of 1 gram per cubic centimeter or 1,000 kilograms per cubic meters. This is a constant value of the density of water. All right, and if I give you a specific water of 1.2, if you really want to know what will be the density of that new liquid, the only thing that we have to do is, because we have the density of water divided, it has to still multiply. All right, so in this relationship, how we can find out the quantity of density of liquid given by specific gravity. In chemistry, this specific gravity is the same situation. The only thing that changed is the name. Instead to say specific gravity, in chemistry, the name of that situation is relative density. In Spanish means densidad relativa. Relative density or densidad relativa is the relationship between the density of any liquid divided by the density of water. In physics, is the same situation. Specific gravity with a relative density, both are the same situation. All right. So, and finally, including the first unit on this situation, we're talking about the pressure. What is the pressure? Well, the pressure in any object will be reached by the relationship between the applying force per unit of area. Well, as soon as you can see, pressure P equals force divided by area. And we have the units, international system and British system. The relationship between units per meter square is called Pascal, in honor or Blaise Pascal, who is determined the Pascal principles. We're going to study later. In a couple of lessons, we will know what will be the principle, the principle of Pascal. Okay, and there's a singular value. If we are applying force in a small significant area, what happens with the pressure? Will increase or decrease? If we are applying a force in a smaller area, what do you think? What do you think, guys?
Can you repeat the question again, Mr.?
What happens with the pressure when we apply for any object if you are applying some kind of force in a small area? What happens with the pressure? Will be increase or decrease? I'm going to say in Spanish, ¿qué pasa con la presión si usted aplica una fuerza en un área reducida? ¿Aumenta o disminuye?
Si la fuerza es grande y la área es pequeña, dice.
Sí, o sea, una fuerza cualquiera, póngale que sea la misma, 100 newtons, y lo aplique en un área bien pequeñita. ¿Qué cree usted que pasa con la presión? ¿Aumentará o disminuirá?
Yo digo que aumenta.
Correcto. It's increasing because it's a fraction. Remember, as soon as we have a smaller unit for the denominator, the fraction will increase. For that reason, if we have a smaller area, the pressure will increase. But if we have applying the force in a big area, what happens with the pressure will decrease. For that reason, I don't know if you ever seen a magician trick. I don't know if sometimes when you see that one, when the magician says, I'm going to pull my strings or something like that, because this magician is lying down in a bed of nails. I don't know if you've ever seen that before. This is a bed. It has a one nail, another one, and he's lying down in that bed and says, nothing happens. because I'm stronger man than word, he said. Well, there's a physical explanation. Because he's lying out in a bigger area, the applying force in that situation is that way is distributed, for the manner of speaking, for every nail in that situation. That's why he can support the reaction force in the nail. But I really want to challenge that same addition. What happens is instead he has a bed of nails, okay? But instead to line up in all these nails, we have the same bed, but I really want to know if you really want to line down with this bed with one singular nail. What do you think what will happen? ¿Qué cree usted que pasaría si se apuesta? Se le entierra el clavo, pues, así es sencillo. Right? Because in one single nail, that the entire weight for this man will that will be enough. That won't be enough to support this nail. For that reason, they will work past the skin of that guy. Okay, this is a similar explanation what happened in this equation. So, in supplementary words, what will be the function of pressure? Pressure is the relationship between the force by unit on area. If we are applying force in a smaller area, the pressure will increase. But if we are applying a force in a bigger area, the pressure will decrease. This is a simple Golgi rule. Okay? Do you have questions on this part? Yes or not?
No.
All right, then. What will be the units? Okay, just to explain you already. The units in this situation is international system, pressure and Pascal. These are the relationship between Newton per meter squared. The unit of force is Newton, and the unit of area is meter square or square meter. Okay. What happened with that unit in the Bridges square? The Bridges system, sorry. In the Bridges system, if you see, we have pounds per square inches. That means this letter P is I. Where have you ever seen that letter before? PSI. Have you ever seen this symbol already?
Yes.
In the wheels of the car, right? Well,
Yeah.
exactly. PSI means pounds of square inches. In that kind of unit, we're going to use the British system in the wheels of the car. But the reason the applying force is given by pounds and the area is given by square inches. Okay, this is going to be just like the unit 1.1 in that situation. Okay, we're going to learn how to calculate density, pressure, and a specific weight and a specific gravity. And remember, if you have some doubts, questions, don't hesitate to let me know. All right. So, do you have questions about that? Right? Yep. Okay. I'm going to write the first example. And remember, if you have that question, don't hesitate to let me know. Okay, the first example says, the problem number 6. Sorry, the problem number 1. So the example number 1 mentioned the 4 tires of an automobile. The 4 tires of an automobile. The 4 tires of an automobile are inflated. are inflated to a gauge pressure of 2 times 10 fifth power Pascal. Okay. Pascal. Each tire has an area of an area of each tire has an area of 0.024 square meters. Okay, square meters in contact with the ground. In contact with the ground. In contact with the ground. The question is, determine the weight of the automobile. Determine the weight of the automobile. When you copy that, let me know, all right? Okay. Ready or not yet?
Wait, mister, wait.
Okay, when you're ready, let me know, all right?
Ya.
Yeah, okay, right. So remember, every time before to solve any physics problem, remember the first thing that we have to do is determine the data or any problems. For example, in this data, what do we have in this situation? First of all, we have the pressure, the Gauss pressure. Gauss pressure is the amount of pressure that we can calculate without including the error, the supplementary word. This Gauss pressure, that will be 2 times 10 at the fifth power Pascal. And after that, we have the contact area. But if we read the problem, at the beginning of the problem says, the 4 tires of an automobile are inflated to the Gauss pressure of 2 times 10 at the fifth power Pascal. The 4 tires. And the problem mentioned each tire has an area of 0.024 square meters. I have a question for you. That will be the value of the area that we're looking for, or we have to do some kind of different way to put in the data. What do you think that we have to do?
Shouldn't you multiply times each tire?
Exactly. And how many times we're talking about? 4.
Four.
Exactly, right? So the only thing that we have to do when we multiply 0.024 24 multiplied by 4, and the area that we're supposed to be looking for, that will be 0.096. 0.096 square meters. Why? Because we are talking about the 4 tires. And if you read the problem says, each tire has an area of 0.024 meters square or square meters. That means if you really want to compare the 4 tires, we're supposed to multiply by 4, so we have the value of the area. So what is the question? Determine the weight of the automobile. What is the weight? The weight is a force, right? For that reason, the only thing that we have to do is looking for what will be the applying force, and that we're talking about that weight, okay? So what will be the first step? First of all, we're going to apply the formula for the Pascal principle. So as you can see, pressure, that will be the product or the division between force divided by the area. And because we're looking for the force, the area divide passes to multiply. For that reason, force that will be equal pressure times area. Okay? Well, in simplementary words, the force that will be equal to pressure 2 times 10 at the 5th power, and instead to write Pascal, if you wish, we can transform the unit of Pascal between the quotient between the quantity of newtons per square meters, right? Because the Pascal is another way of extension, another way of saying Pascal. In the area, we have a 0.096 square meters, okay? And square meters with square meters can be calculated for that situation. The quantity of force that we are looking for in this case will be 2 times 10 at the 5th power multiplied by 0.096. The answer will be 19,200 newtons. And that's it. That's all that we have to do in this situation. Questions? Simple, right? Facilita, facilita. Vamos a hacer otro ejercicio. Okay, this is another one. The example number 2. There's a copy over here. In the example number 2 says, calculate the mass of a solid gold rectangular bar. Calculate the mass. Calculate the mass of a solid gold rectangular bar that has dimensions of 4.50 in this situation will be 4.50 centimeters, 4.50 centimeters, comma, times 11 centimeters, times 11 centimeters, times 26 centimeters. 26 centimeters. Okay, when you're finished to copy the first example, let me know. Okay. Cuando terminen el primer ejemplo, me lo hacen saber, mis estimados aprendices. ¿Ok? Okay. During the class in Google Classroom, in the Facebook class, I'm going to upload density table of these objects and substance, right? In that situation, you probably never gave us the density of the goal because we're supposed to have a table. Don't worry about it. I'm going to upload in the admin or EduBox platform or Google Classroom. I think that will be useful in EduBox platform if you wish, okay? And you're going to find out the table of density of any bodies and so, okay? So in this situation, the problem asking for, calculate the mass of a solid gold rectangular bar that has dimensions over of 4.50 centimeters times 11 centimeters times 20 centimeters. In this situation, what we're going to do? First of all, the data. What will be the density of the gold? Justin explained you already. This is a value is given by the density table for liquids in some kind of substance, okay? And the density of the gold has a value of 19,300 kilograms per cubic meter, okay? This is going to be the density of the gold. So I have a question for you. How can we obtain the volume of this rectangular solid bar? How can we obtain this volume? Any idea? How can we obtain the volume of that rectangular solid bar of gold?
By multiplying the 4.5, 11, and 26.
Exactly. Multiplying three of them. 4.50 times 11 times 26. And we have a constant value of 1,287 cubic centimeters. And the question is, calculate the mass of this solid bar. So in the supplementary work, we're supposed to be looking for what will be the mass in that situation. What are we going to do? Before to do that, you see the unit of the density is kilograms per cubic meter. Okay? We have the volume, yes, but the volume is given by cubic centimeters. We have to change these cubic centimeters into cubic meters to cancel the same unit, and we're going to have the answer in kilograms. How can we do that? Well, it's simple. The only thing that we have to do is, because we really want to transform cubic centimeters, all right, into cubic meters, the only thing we have to do is divide this quantity into 1 million. In supplementary work, 1 times 10 to the 6th power cubic centimeters, that will be equal to 1 cubic meter. So supplementary work, this quantity divided by 1 times 10 to the 6th power, and the answer will be 1.287 times 10 at the negative 3rd power cubic meters. Okay, so we are full prepared. We'll calculate them now. Okay, what we're going to do? Well, simple. Now the only thing that we have to do is calculate the mass. Remember, density is the relationship between mass divided by the volume. And because we're looking for the mass, density times volume, that will be equal to the mass, right? Because the volume is divided by to multiply. So mass will be equal, density, 19,300 kilograms, cubic meters, multiplied by 1.287 times 10, and the negative third power cubic meter. Sorry for that. I'm going to fix it. I don't like it at all. No me gusta cómo se mira. Lo voy a poner aquí. Again, the mass will be equal density 19,300 kilograms cubic meter multiplied by 1.287 times 10 negative third power cubic meter, and the result will be given by 24.84. 24.84 kilos. And that's it. That's all that we have to do in this situation. I don't know if you have some questions into this part. Preguntas hasta ahorita. ¿No todo claro? Todo azul, mis estimados aprendices.
Mister, ¿de dónde es que
Ajá.
sacó la density?
Es que en el texto hay una tabla de densidades y estándares. Entonces, esa tabla de densidades yo se la voy a proveer, es decir, se los voy a subir en la plataforma de Dubox, ¿verdad? Para que ustedes miren las densidades de las sustancias y de algunos materiales. En este caso, la densidad del oro ya está dada. Entonces, yo se los voy a proveer, ¿de acuerdo? Y el volumen es la multiplicación de los tres elementos, 4.50 por 11 por 26, que nos da 1287 centímetros cúbicos. Y para pasarlos a metros cúbicos, lo único que hace es dividirlo entre 1.000.000. ¿De acuerdo? Y ahí lo tienen en metros cúbicos. ¿Entendió?
Gracias, mister. Sí, sí.
Bueno, vamos a darle un print screen a esto. Para no perder la costumbre, déjenme buscar el grupo Algebra 2 en PESEX. Miren, para que vean que no he perdido la costumbre, ya les mandé una captura de pantalla por si las dudas no se miran muy bien. ¿De acuerdo? Entonces, si no hay preguntas, mis estimados aprendices, si está todo claro, todo azul, pues esto sería la clase por el día de hoy, porque creo que ya terminó. Si mi memoria no me falla, a la 1:10. Entonces nos estaríamos viendo que el día de mañana vamos a transmitir directamente desde Valle de Sula. Aunque les debo que confesar, ¿verdad? Que algunas cositas como el equipo nuevo me va a costar adaptarse, ¿verdad? Pero al final todo va para bien, ¿verdad? No se preocupen. Pero que la vamos a tener, vamos a tener. ¿De acuerdo? Bueno, entonces, si no hay preguntas, está todo claro, pues los veo el día de mañana a la misma hora por el mismo canal.
Gracias, mister. Qué buen día.
All right, guys, take care of yourself. Bye,
Bye,
bye.
mister.
Cuídense, muchachos, Dios los bendiga, los guarde, los cuide. Los veo mañana.
Mister, yo tenía una preguntita de cómo fue que sacó de centímetros cúbicos a metros cúbicos, porque vio eso.
Se divide entre 1.000.000. Entre 1.000.000.
Entre 1.000.000.
Entre 1.000.000. Correcto.
Porque es
O sea,
cúbico.
1 metro, sí. Es que mire, usted sabe que 1 metro tiene 100 centímetros.
Sí.
Ajá. Y si hablamos en área, 1 metro cuadrado es como que usted multiplicara 100%. Y entonces le queda 10.000. ¿Cierto? Y ahora, 1 metro cúbico es como que usted quiere llevar a 100 a la 3. ¿Me explico?
Sí.
Entonces, de esa manera, 100 a la 3 le va a quedar 1.000.000. Por eso es la relación. O sea, en pocas palabras, 1 metro cúbico equivale a 1 por 10 a la 6 centímetros cúbicos.
Ok. Ya entendí.
Bueno,
Gracias.
a la hora.
Gracias.
Pero mañana vamos a hacer ejercicio más divertido. Esto es para precalentamiento, ¿no? Para que se divirtieran con la fórmula.
Gracias.
Cheque, pues, bendiciones. Nos vemos mañana. Bye, bye. Take care of yourself. Nos vemos, Jean. Cuídense. Un gusto. Bye, bye.